Hello all, in our previous video we discussed about the network basics and its principles. In this video we are going to discuss some of the problems network basics and principles. So first question, the current in the given circuit with the dependent voltage sources. Let's find out by using KVL. We use KVL here, 24 volt minus I because current through 1 amp, then plus 2 VB, then minus VB is equal to 0, 24 minus I plus VB is equal to 0, I is equal to 24 plus VB, and VB is equal to 3I minus 3I, no, plus 3I. So I is equal to 24 plus 3I, when it comes this side, 2I is equal to 24, I is equal to 12 amperes. In this question, for the circuit given in the figure, the power delivered by 2 volt source is given by, let's consider the current here delivered by 2 volt source is capital I, as the current here is I, small I. The 2 volt voltage is across the 1 ohm resistance, so small I is given by V by I, V by R, V is equal to IR, V is equal to IR. Oh yeah, so V by R means 2 by 1 is equal to 2 amperes. If 2 amperes going here, 1 ampere is coming here, and another 1 ampere is coming from the source, 1 ampere is coming from this source. So main current will be 1 ampere. We know that power is equal to V into I, so 2 into 1 is equal to 2 watt. Next question. So in the circuit, the current through the inductor L is, we always know Z, impedance is given by root of R square plus XL minus XC whole square, right? As like RLC circuit, so parallel RLC circuit, so IR is given by 5 square minus 3 square, square root of 5 square minus 3 square, 25 minus 4 square, 25 minus 16, which is equal to square root of 9, which is equal to 3 amperes. So 3 amperes coming here. Let's write the vector diagram. We know that this is IR, this is IC, so this is IL. Always IL leads, IL lags, and IC leads. So IC is 4 ampere, in order the IR is 3 ampere. So how to find IL? So IL minus 4 whole square plus IR square is equal to, this gives IL is equal to 8 amperes. Next question. Okay, for the circuit the value Vs is 0 when I is equal to 4 amp. The value of I when Vs is equal to 16 volt is. So this is a typical superposition principle problem, but it can be done by basic laws also. Here given Vs is 0 when I is equal to 4 amps. So when Vs is equal to 0, I is equal to 4 amps. So let's consider circuit like this. Is is like this, 2 ohm is there, 2 ohm, So Vs is 0, so it is short circuited. So what will be the I is 4 ampere, right? So by using this we can calculate what is the Is. If 4 ampere is coming here, here also 4 ampere is going, so total main current will be 8 ampere. So Is is equal to 8 ampere, right? Right. Next, the value of I when Vs is equal to 16 ampere, right? So 16 volt, sorry. So Is is 8 ampere. 2 ohm is there, here 2 ohm is there, there is 2 ohm. Vs 16 volt, right? So 16 volt is coming here. The 16 volt is connected here. Apply KCL. So this is minus 8 across this node, KCL, plus V1 by 2 plus V1 minus 16 by 2 is equal to 0. V1 is equal to 16. I is equal to V1 by 2, which is equal to 16 by 2, is equal to 8 ampere. Here, in a network made up of linear resistor and ideal voltage sources, value of all resistance are double, then the voltage across each resistor. Here the main point is ideal voltage source. In ideal voltage source, when value of all resistors also doubled, the voltage across each resistor does not change. It remains constant always. Then consider what is the power delivered by 24 volt source, right? Right. Here 24 volt is across the 6 ohm resistor. So IFL is equal to 24 by 6. 6 4 74. So 4 ampere. IFL is 4 ampere. 4 ampere current is going here. What is the power delivered by 24 volt source, right? So we always know P is equal to VI, right? 4 ampere is going here. Here how much ampere will be going? 4 into 2, 8 ampere is going. 4 ampere is going here. So 12 ampere is going here. So V into I is equal to 24 into 12, which is equal to 288 watt. So option is D. Next question. Here, if the current I of t, what is the value of R, right? How to find this R? Tan theta, right? Tan theta is equal to XL by R. So R is equal to XL by tan theta. What is XL? J1 R1. We consider 1 because let's see, this is a modulus. So 1 by tan 30. Right, what is the value of tan 30? 1 by root 3. 1 by root 3, which is root 3 ohms. Next question. So what is the value of current I in the circuit shown below? I is here. So how to do this problem? Let's do by using KCL. Let's the voltage V. So here V minus 140 by 2 plus V by 4 plus V minus 70 by 1 minus 70 is equal to 0. So V by 2 minus 70 plus V by 4 plus V minus 140, right, is equal to 0. V by 2 plus V by 4 plus V is equal to 210, right? 1 by 2 plus 1 by 4, 3 by 4 V. Sorry, 3 by 4 V plus V is equal to 210. What is 3 by 4 plus V? 7V by 4 is equal to 210. 7 ones are 7 3s are 30s are V is equal to 120 volt. So what will be the current? V by 4, 120 by 4, 30 ampere. So answer option C. Next question. For the network shown in the figure, what is the voltage across the current source? So what is the current of the source here? V is the current, I is the current through the resistor. So applying mesh analysis, V minus of minus I, or so option is equal to V plus IR. Because current is here, we are assuming current like this. This current is here, so minus of minus IR, V plus IR. So what is the voltage across the current source for the given below circuit, right? What is the voltage across the current source? This is the current source. Let's apply same principle. That's the voltage kcl, V minus 10 by 5 plus V by 5 plus, sorry, this is not plus, this is minus 5 is equal to 0. V by 5 plus V by 5 is equal to 5 2s are minus 2 minus 5 7. 2V by 5 is equal to 7, right? Right, 1 second. V by 5 minus 2 goes here, minus, okay, 2V by 5 is equal to 7. So 2V is equal to 7 5s are 35. V is equal to 35 by 2, 17.5. Stands at 17.5 as option D, right? Option D. Yes, option D. Okay. 17.5. Next question. Let's see. The power dissipated in a controlled circuit means they are asking power dissipated by 2VA. So how to do this? Let's apply the KVL like this. So plus 36 minus 59 minus 2VA minus VA is equal to 0. 36 minus 59 minus 3VA is equal to 0, right? We know that VA is equal to 7I, right? So applying 7I, 15I minus 3 into 7I is equal to 0. 36 is equal to 36I, I is equal to 1 ampere, right? So 1 ampere is the current, VA is 7I, VA is equal to 7. So power is equal to 2VA into I. Why 2 comes? Because it is a controlled source or dependent source. So 2 into 7 into 1 is equal to 14 watt. Answer option D. Next, the value of C is so chosen that circuit impedance is maximum. Then I1 leads I2 by here. So I1 always leads voltage by 90 degree because it is flowing through capacitor C. Whereas I2, sorry, don't mistake, I2 here 2 ohm. So we already know tan theta is equal to XL by R. So 2 by 2, which is equal to 1. So theta is equal to 45 degree. So now XL is like this, XC is like this because they are opposite to each other. Already XL is lagging by 45 and XC is giving you 90 degree lead. So 90 plus 45, which is equal to 135 degree. So option D. For the circuit given in the figure, the current through L and voltage across C2 are respectively, right? Here the current source is DC source. So when DC is applied, capacitor are open circuited because 1 by XC, 1 by 0 infinity, so resistance is infinity, so it is open circuited. L are short circuited, XL is equal to 0, so short circuited. So applying this, we can write like this: I so capacitor is open circuited, whereas L is short circuited. Again capacitor open circuited, and R is here. They are asking voltage across C2 and current in through L. Current through L is I, and voltage across C2 is I into R. So option D. Next question. So in the circuit, the switch is moved from position A to. So from the circuit we can write E2 as I into R plus L into di by dt, right? Right. Then at t is equal to 0, E2 is equal to minus 8R, right? 8R, because I of 0. 8R plus 2 into 3 at t is equal to infinity, that is when at switch B, position B. So E2 is equal to 4 into R. So from 1 and 2, R is equal to 0.5 ohms, right? Right. Next question. Here the capacitor in the circuit shown is initially charged to 12 volt, right? With S4, S1 and S2 open is closed at t is equal to 0, while S2 is closed at t is equal to 3 seconds. So waveform of the circuit, right? See, we always know tau is equal to RC. This is, what is this time constant? It gives the amount of voltage decay in charged capacitor, right? Here capacitor is charged to 12 volt, right? They are opening S1 at t is equal to 0. No, yes, and opening S2 at, sorry, they are closing S1 at t is equal to 0 and S2 at t is equal to 3 seconds, right? When S1 is closed at t is equal to 0, means S1 is closed at t is equal to 0. So the circuit becomes like this: 12 volt is there, 1 ohm, 2 ohm, right? Circuit becomes like this. So I is equal to 4 amp at t is equal to 0. At t is equal to 3 seconds, voltage will be like this: 1 ohm, second resistance is shorted, this is S2. So I will be 12 by 1, which is equal to 12 ampere. So which of the following gives the answer? Option A. Thank you. We are going to discuss another set of 15 problem in next video. Thank you all.